circuit board is also known as PCB. It is the backbone of all modern electronic devices. Think of it like a city. These dense circuits up there, like the intricate traffic network in the city, cars weaving in and out of traffic. It's like moving current in a circuit. An electronic component mounted on a circuit board is like every different governing body in the city. I have to say this is a great invention. Assuming there's no circuit board, trying to connect the various electronic components, just like in the video, there will be a mess of wires. It is not only complicated but also easy to make mistakes. In the last century, 1936, Paul Eisler is aware of this serious problem. I came up with the concept circuit board. A conductive copper circuit is printed on a non-conductive material plate, then put the electronic components installed on the said circuit. This is the prototype of the circuit board development up to now, and that resulted in the high precision that we see now. Dozens of layers of complex circuit boards. Here we take a look at it. This amazing circuit board. How is it made? First, the engineer will be on the computer, make proofing plans submitted by customer, check whether the design is reasonable, then combine their own equipment and process capabilities, fine-tune and optimize the scheme, identify actionable solutions, will be printed one by one onto this transparent, sensitive film. The principle of photosensitive photography will be used later. This pattern is transferred to the board by projection. This double-sided copper-clad plate is the raw material for the circuit board. It is made of wood pulp paper or glass cloth and epoxy resin by hot pressing. To be precise, it is now officially entering the production step of the circuit board. This device is called a feeder. It will cut the raw material copper-clad sheet to the size of the design specification. In the transmission process, it will also be cut around the copper-clad sheet. Sanding. Make the edges smoother. Treated copper-clad sheet. A photosensitive film is placed on its surface. This film is sensitive to light. It solidifies wherever light hits it. It creates a kind of zone protection on the copper-clad plate, and the areas that weren't hit by the light will wash off easily. This will link to the following graphics. The transition step plays a key role. In the first 1 minute and 15 seconds, there is an introduction to the design of the graphics will be printed on sensitive film. This sensitive film is similar to the negative of a camera. Position the sensitive film against the coated copper plate. Put it on an exposure machine to take pictures away from ultraviolet light. Will be sensitive to the graphics on the film. Transfer to a copper plate coated with a photosensitive film. This solidifies the film in the exposed area. There is no exposure area of the photosensitive film. Will be in the next development step, using the weak alkalinity of the developer potassium carbonate. After washing away the sensitive film without exposure area, we'll reveal the original copper surface. In the next etching step, using hydrochloric acid compound potion, once we've eaten away all the exposed copper, that's the prototype of the circuit board. The circuit is very fine. It's almost impossible to tell with the naked eye. Next, go to OE for an inspection. It's using optical machines. Scan the produced PCB board. Compare the scan results with the customer's original design on the computer. Those found to be substandard will be disposed of. Check the qualified circuit board will proceed to the next step. Solder shield to delay the board oxidation ash accumulation. A layer of solder resistance ink is applied to the surface. The main component is talc powder resin and green pigment. Is that why most boards are green? Finally, the impedance on-off test of key points should be carried out.